Hello again, algebra students. We're going to move on now with solving systems of equations. We've already spent 2 days with graphing systems of equations to see where the two lines would cross and get our solution, or see that the lines are parallel, so there's no solution, or the same equation, so we would have really infinitely many solutions, all points on the line. Graphing is really nice sometimes. However, what if the lines don't cross at a nice point where I can see where they're crossing? What if the lines do cross, but they would cross at really, really big numbers, so I would have to have a huge piece of graph paper, or really potentially really small numbers, so negative numbers. So graphing is nice to get an idea of what those solutions are, but it's not always the most convenient way. Now, the 2 days that we spent on it, we absolutely picked points and lines that would be really convenient to graph. However, we have other methods. So, well, this is not wanting to move ahead for me. There we go. So the second method that we're going to work with is called substitution. Well, you should know what substitution is, right? Substitution is when we put one thing in place of something else. And when I ask you, when have you already used substitution? I know that everybody loves checking their answers, but every time you substitute your answer into an equation to make sure it works, that is substitution. When you're taking your answer, your number, and substituting it in for a variable. There are other times when we've just asked you to say, what is the value when x equals, and we'll pick a number. When we graphed lines, we used a table of values. We substituted in for the x's. So you should be comfortable with doing the substitution. It's just that today our substitution isn't just going to be substituting a number in for the most part. So we're going to have to make sure that we have one of the variables, either the x or the y, all by itself today, so that we can do our substitution. And to be perfectly honest, today, we're going to have that part done. We're going to make that easier for you today. And in the next lesson, we'll have to ask you to get one of the variables alone. So step one will be done for you today. Solve for one variable. That means get it to be either y equals something or x equals something. And again, that'll be taken care of today. We'll take whatever that x or that y is equal to and substitute it into the other equation. And then when we do that, the whole reason for doing that substitution is because then we will have one variable. We'll either have all x's or all y's, and we can solve that. Once we know that variable, what x is equal to or what y is equal to, we can take that and substitute it back in to find out the second or the other variable, the one that we started with. And then obviously checking our solution is where we substitute those in to make sure that it works. So I've got those steps over here, kind of small on the left side of the screen. And in our problem, you can see that in this equation on the top, I have the y by itself already. This looks like slope-intercept form. I don't need to make them both look like slope-intercept form. Remember, we're not graphing. I don't need them to both say y equals. However, that is what the y is equal to. So instead of y in the other equation, wherever there's a y, I could take the y out and put in that x plus 1. Now I'm going to suggest when you do your substitution, use parentheses, even if there's no distribution. I want to see that substitution done with parentheses so I can see that's where it was going in that new equation. So 2x, and now instead of y, I'm going to say x plus 1. And again, because there was no distribution, those parentheses don't really mean anything other than to just show my substitution. So I can really ignore those. I could even put a 1 in front of that x. Now remember, we're going to be solving this for x. But these x's are on the same side. 2 x's plus 1 more x, that's 3x. And then I want to get rid of that adding 1. So to get rid of adding, I would subtract, or do a keep change there. So I get that 3x equals negative 3. And then we'll divide, and we'll find that x is negative 1. Some students want to stop right there. They think, yay, I found the x, I'm done, but you're not done. That's the x. I still need the y. So I would go back to this equation where it says y equals, that same equation again, and say y equals, well, instead of the x, I would put in what x is equal to, which is negative 1. So y equals -1 plus 1 is just 0. My ordered pair for this problem, remember ordered pairs are always x and then y, -1, 0. Make sure you're taking those two variables, putting them back together into one ordered pair. Now, again, I really should check this in the other equation now. So if I had that x was -1, I would have 2 times a -1, so it's really -2. -2 plus 0, oh yeah, that is equal to -2. That worked in the first equation because that's how we found that variable, and it works in the second equation. That's the one point that works for both equations. In this problem, again, I know what the y is equal to. This is the y. In the other equation, doesn't matter if it's the top equation or the bottom equation, in the other equation, which happens to be the top one, I'm going to take the y out and I'm going to put this stuff in its place. So I'll have 2x plus 2, and then here's my parentheses. Instead of the y, I'm going to say 5 minus x. And again, we're good at solving equations. We know how to solve equations. Let's distribute. So I'll have 2x plus 10 minus 2x equals 10. Well, right now, you should be looking at this and worrying a little bit. This is a little bit wonky, right? When I combine my x's, don't forget that's really a -2x. 2x plus -2x is 0. The x's are going to go away. Don't write down 0x. They're just gone. What I'm left with on the left side is 10. And on the right side, it's also 10. Now again, if we were just solving a regular equation, we would end our problem like that and say any real number. But again, remember, think about what this really means. This means that these two lines are the same. And when we get that, our answer is all points on the line. Every single point that was on the first one would also be on the second one. If you would get them both to be slope-intercept form, they'd be the same equation. For number 2, this time I have an x by itself. Remember, it doesn't have to be the y that's by itself. This problem happens to say x equals, for this equation right here, x equals -2y minus 1. This is what the x is equal to. That stuff is going to go instead of that x. So I'll have 2, and then instead of x, I would put this stuff in parentheses. Minus y equals 3. And again, we're good at solving equations. Distribute. -4y. 2 times a -1 would be a -2. I'm going to sneak a 1 in front of that y, and I'll even do a keep, change. Give me a little bit more space here. When I combine my y's, remember they're on the same side. -4y and -1y is -5y. Then I want to get rid of my -2 with a +2, or adding 2. -5y equals 5. And then we're going to divide by -5. So that means that y equals 5 divided by -5 is -1. Now that I know what the y is equal to, I do need to find the x. So I would go back to this equation right here. Because it says x equals, that's what I'm looking for, is for what x is equal to. So x equals -2 times the y was -1. -2 times -1 is 2, minus 1 is 1. So my ordered pair, the x goes first, the ordered pair is going to be 1, -1. And if we would check that with the other equation, top equation, 2 times 1 is going to be 2, minus a -1, 2 plus 1 is 3. Yep, that one works. Number 3 is actually a really nice, easy problem that tends to confuse students because they try to think about this too much. They try to second guess themselves. says for the second equation, it says that x equals y. It means that x and y are exactly the same thing. So instead of the x, I could just put a y right there. So that equation would then be y minus 3y equals -1. I could put a 1, I could do a keep, change. This is going to be -2y equals -1. When I divide by -2, y equals negative divided by negative is a positive 1/2. Well, then when I look at this equation again, it said that x was equal to y, so whatever the y was, then the x is exactly the same thing. So my ordered pair would be 1/2, comma 1/2. Oops. And if I would check that in the top equation, I would have 1/2 minus, well, 3 times a half. That would be -3/2, or -1.5. So 1/2 minus 1.5, that would be -1. Use a calculator if you don't like those fractions, but 0.5 would have been fine for both of those as well. In number 4, we're back to a problem where the y is by itself. So the y is equal to x plus 1. That's what the y is. That's going to go in place of the y. So I have x minus 2, and then in parentheses, I'll put the x plus 1. And then we solve. I would even put a 1 in front of that and a 1 in front of that. So I've got 1x plus a -2x plus a -2 equals -3. When I combine my x's, 1 plus a -2 is going to be a -1x. And then we would add the 2. So I have that -1x equals -1. And we do our division, and x is equal to a +1. Now that I know what x is, I can go right back to this equation again and say, well, let's find the y, because the y is going to be x plus 1. That's 1 plus 1, that's 2. So my ordered pair, x, y, would be 1, 2. Here, x is by itself. This goes in place of the x. So I've got 2 times 3y plus 5 plus the other y equals 3. I'm going to try to solve these a little bit faster so we can save some time, but feel free to pause if you need to. 6y plus 10 plus 1 more y. Combining my y's, I've got 7y plus 10. Seems like I can't get away from those bells. So dividing by 7, I'm going to get that the y is, that's supposed to be a 7 there, sorry. Y is going to be -1. And if the y is -1, I could go right here and say that the x is going to be 3 times a -1 plus 5. That'll be a -3 plus 5 is 2. So my ordered pair, x and then y, would be 2, -1. It's a weird looking 2 comma, sorry. And for my last problem, again, I have the y by itself here. This is going to take the place of the y. I'm still going to use parentheses, even though there's no distribution, just to be in that habit. So when I combine my x's, I've got 5x plus 5 equals -5. If I subtract this 5, I'll have that 5x equals -10, and x is -2. If the x is -2, I could come right here and say, then the y is going to be 2 times -2 plus 5. So -4 plus 5 gives me that the y is equal to 1. My ordered pair, again, x, y, -2, 1. Today's worksheet is going to be about solving systems of equations. It's the first day, day 1 worksheet. Make sure that you check your answers in Schoology. You should be either substituting your answers back in or just check it with the answer key. And then don't forget about the formative in Schoology. Let me know if you need any help.